last time we built the content of our page in HTML, we styled it in CSS, and we learned how to take a template from HTML, fill it out, and inject it onto the page with JavaScript. And in this video, we are going to take the trivia game that we have in its current state and actually code the logic that allows us to check whether the user got the question right or wrong. And then, regardless of whether they got it right or wrong, take this question off the page, put the next one on the page. And so we have to learn two new fundamental programming skills to be able to implement this. One is conditionals, and the other is arrays. And so conditionals are the way that we can embed deciding logic into our code. You can think of it as our code is now implementing some kind of flowchart. And the other, with arrays, the idea is that we are going to take a series of things, store them into one variable called an array, and then we can run some logic on each element in that array. So that array is going to be filled with our trivia items, and then we're going to write our logic in such a way that we can say, go through each item that we have stored here and display it on the screen, check whether the user got it right or wrong, move on to the next one. So to kick things off, we're going to go to a whiteboard and talk about conditionals. And specifically, we're going to start off with talking about if statements. So we'll build in a separate file a little demo app that uses those modal pop-up windows, the prompt and input, to prompt and alert, to go ahead and ask the player if they want to play the game. And then if they say yes, we'll go ahead and ask them a trivia question. And then we'll check whether they got it right or wrong. So the way that we can represent this logic is with a flowchart. So that first thing that I said we're going to do is ask the player if they want to play. So ask player if they want to play. And then we're going to have this branch that comes out. So if they say yes, one thing will happen. And if they say no, something else will happen. And this branch here is where the conditional is going to sit in our code. So we're going to have a structure that allows us to say, if the player says yes, do this thing. If the player says no, do this other thing. Let me get rid of that so we can have a nice clean flow chart. So if they say no, this will be easy. We'll display an alert that says maybe next time. And if they say yes, then we have to actually display our question. Whoops, that's an ugly line. Display the trivia question. And here we're going to have another branch, so the player is going to get a chance to answer the question. Well, I guess we could write that in here. And collect answer from player. So we got another one here. If the player got it right, player entered correct answer. And this will be the same thing, but incorrect. That was one too many swoops there. There we go. That is answer. And here we'll do whatever, this will be our win logic. And we'll display some kind of like try again logic here. So let's zoom out and see it all together. And flowcharts can be a useful way for you thinking about your own applications and planning them out. Is grab a piece of paper, do a little bit of flowchart here, and map out the logic that you want to implement, and then use this as a guide as you're actually going to implement the code. Okay, so let's make this. We're gonna flip back over to the code. I'm going to open up index.js where we were working before, and I'm going to show you something that we can do with JavaScript. So I'm going to create a new file here. We'll call this conditionals demo.js. And inside of our index, remember how we made sure that when we were bringing in scripts, we were saying that they were modules, which enables the import and export syntax for JavaScript, which allows us to do things like this: import conditionals demo.js. So when we import a file like this, it is going to go ahead and run whatever we put in this file. So if I say console.log conditionals demo and check it out in the browser, we should see that print out. And if I go back to my index and comment this out, we should no longer see that print out in the console. So this will be an easy introduction to using the import syntax so that we can kind of work in this separate file, do a little bit of demo, and then turn it off by just no longer importing it here. So we don't have to mess around with adding a bunch more scripts to our HTML file. We can use our index.js as the kind of decider of what code actually gets loaded into the page. And we'll talk about exporting, especially as we dig into React and into building external modules. But for now, we've got this import syntax. So in our conditionals demo, let's start building out that whiteboard. So we want to build this first branch where we ask the player if they want to play. If they say yes, we'll do one thing. If they say no, we'll do something else. So we are going to use our prompt that we saw when we first started learning JavaScript to ask a question, which pops up a little window. So we're going to say the play response is equal to a prompt, and we'll say, would you like to play a game? And then we can use this new syntax, an if statement, to check whether what they said is equal to yes. And if so, then we can say, great, let's play. So this syntax here is an if statement, and we have in parentheses a condition, so something that evaluates to be either true or false. If it's true, then whatever we put inside of this code block is going to run. So we could have as many lines in here as we need. Right now we're just going to print out, great, let's play. So I'm going to pop open my browser, type in yes, all lowercase, great, let's play. And if I try typing in, whoops, let's reload this, let's say no, nothing happens. And also if I try typing in yes in all caps, we see that nothing happens. So this check that we're doing here, this 3 equal sign operator, is taking what's on the left and on the right and making sure that they're exactly equal. So it has to be yes, all lowercase. So one thing we can do here is actually take this string and convert it to lowercase. So all strings in JavaScript have a method that lives inside them that we can access using dot notation and invoke. So this is a function that lives inside of the inside of our string objects that allows us to take it and convert it to lowercase. So if I type in yes in all caps, this is going to give me back yes lowercase. So I should be able to now go back to the browser, refresh the page, type in yes in all caps, and get the great, let's play message. So if statements allow us to check if this specific condition is true. And then if we want to run something when that condition is not met, we have an else clause, which looks like this. So anytime this condition is not met, for instance, if I type in no, whatever we put down here will run. So I can say alert, oh, okay, maybe next time. So if I flip back to the browser and try running it again, if I say no, we should now see, oh, okay, maybe next time. So with this, we have that first branch implemented. This is our if, and this is our else. So when we want to do this next part where we display a question and get the answer from the player, we're going to put all of this logic for this branch inside of here after our great let's play. So this would be a nested conditional where we're going to end up with another if statement inside of here to check whether the answer is correct. Before we do that, we got to ask the player a question. So I'm going to say speed response is equal to, and for this I'm going to grab another question that has to do with the movie Speed and paste it in here. So in 1994, in the 1994 movie Speed, what is the minimum speed the bus must go to prevent the bomb from exploding? And for this, once we have it, we can say if the speed response is equal to 50, so exactly equals the characters 50, then we can alert correct. And otherwise, we can alert wrong. So let's try it out. I want to play. Great, let's play. I'm going to type in 50, correct. And then it's always important when you're writing branching logic to test all possible branches. So I'm going to run this again. I'm going to say, yes, I want to play, and I'm going to type in 30. And I get wrong. So it looks like the code we wrote is working. I'm going to add a wrinkle here in that maybe we want to tell them that if they guess 40 or they guess 60 that they're getting close. So we can actually use an else if clause in here to add multiple cases. So if, else if, and then parentheses, we can define another case. So I could say speed response equals 40. Then I can print out almost. And do a similar thing here if the speed response is 60. And the way that the logic executes is this whole block, only one of these things is going to execute. These are all linked clauses. So if the speed is 50, this will print out, nothing else will happen. If it's not 50, it's going to check the next one. And if it matches here, it's going to print out almost, and it's done. It's going to skip over and come down here and finish running whatever other code we put inside of this code block. And it's only if it's not 50, it's not 40, it's not 60, do we get down to this else and have this run. So the order in which you define your clauses for your if statements matters, because whenever it hits the first matching one, that's it for this whole block. It's done. And you can have as many else ifs as you want in here. You can only have one else and one if. You're always going to start with an if. You'll have an optional number of else ifs, and then you will potentially end with an else. But that one is not required. Okay, so let's test it out. Let's see. Run back. Yes, I want to play. Great, let's play. Let's try 40. Almost. Let's say yes. Let's try 60. Almost. And then make sure that it's still working for catching all other cases. Let's type in 100. Wrong. So we were able to create this branching logic And actually, the logic we wrote is a little bit more complicated because there are more than just 2 outcomes down here. We've now made it so that there are 4 possible outcomes at the bottom here. So I want to fill in some information here. We've got this operator that we just saw, which allows us to compare whether 2 things are exactly equal to one another. There are other operators that are quite handy when it comes to making branching logic and comparing things inside of our conditionals. So I'll make sure that this is the MDN documentation for operators in the JavaScript language. I'll make sure that this is in the canvas. And if we scroll down, we'll see some things that are familiar, like the addition operator. We've used this before. You can use it to add 2 numbers together. It'll take what's on the left of the operator, what's on the right of the operator, and turn that into the mathematical sum of those 2 numbers. But it will also work with strings, where you can pass in a string on the left side and on the right side, and you get back that string combined together. There are relational operators, so less than, greater than, less than or equal to, greater than or equal to, which allow you to compare 2 numbers. So for instance, we can say 5 less than 3, we would get back false. 3 less than 3, we would get back false. So these operators allow us to make comparisons between 2 numbers. So for instance, let's say that we had the player playing this trivia game and they got a score of 3, and we know that the last high score registered was 2. So we could have some conditional here say if the player's score is greater than 2, we would alert new high score. So you can use those relational operators inside of the condition of an if statement as well. If we keep scrolling down, we'll see the equality operator. This is the strict equality operator, and this is the strict inequality operator. So if we take a look at this, this does what we were expecting in our code. If we have a number on the left and on the right, if they're exactly equal, we get true. Same for a string. And if we compare like a string to a number, we're going to get false. Those 2 things aren't equal because they're 2 different data types. The non-strict version of these operators, so you leave off one of the extra equal signs, and I recommend that you don't use these. These are non-strict, which means that if you compare 2 types, they are converted to a common format before they are compared. So here, a string and a number can both be converted to a shared format and compared, and since the character 1 is the same as the number 1 here, we're getting true. Using the non-strict version can lead to unintended consequences, so generally steer clear of these. And then there are logical operators which allow us to express multiple conditions together. So, if we wanted to say that some expression over here and some expression over here both have to be true, we can use the AND operator. Or the OR one allows us to express that either one of these has to be true. So to see an example of this OR in action, we can actually refactor what we wrote here. I'm going to grab this. Because we wanted to print out almost, if the score is 40 or the score is 60, we can eliminate one of these branches here and just have one condition. And the way this executes is either side here has to be true for this to run. So our code should still work the same as it had before. So that's conditionals. There's more to dig into here. There's another way to express conditional logic called a switch statement in JavaScript. I'm going to kind of introduce additional syntax as we need it, but this should be enough to get us cooking with creating trivia and checking whether answers are right or wrong. So I'm going to close this tab. I'm going to come back in here and I'm going to comment out this import. We no longer need to import that test code. And let's create a new one here for array demo. And we will import that one. the page. So those prompts should be gone now after you refresh it. We can see our new JavaScript file is linked in here with arrays. And we're going to flip over to the whiteboard to talk about arrays. So let's see an example line of JavaScript here that creates an array. Let's say we're creating an application. We want to store a color scheme or a color palette. So we might say const colors equals, and the syntax for an array is an opening bracket, and then we can put a bunch of values, like let's say we've got red, green, blue. We have a series of values here, and they are simply separated by commas inside of our brackets. So this defines an array, and arrays are useful when you need to store a series of pieces of data together into one variable. And how you can think about this in terms of how it looks in the computer's memory is that there is some chunk of memory, and there are 3 boxes, and red is in the first box, green is in the second box, blue is in the third box. And in terms of terminology and the way that we refer to these elements, when we're talking about the value that's inside one of these boxes, it would be an element. So we'd say that red is an element of this array. And then when we need to sort of pull out these elements from the array, we're going to have to use what's called an index. So this is an index. So if we wanted to pull out red from our colors array and use it, we would have to say colors bracket 0. And this would give us back red. And so index or indices, these start at 0 counterintuitively. So when we're talking about the first element, we're talking about the thing at index 0. And then the second element is at index 1, and so forth throughout the array. In JavaScript, arrays can be mixed types. So we could have had an array that had a string, and then a number, and then an object, and then a Boolean, all as elements within the array, and that would be completely fine in JavaScript. So let's flip over to our script and start seeing how arrays work in practice. So we've got our array demo here. We will create our first array. Let's say we'll go with high scores. So high scores. Let's say someone had 2,000, and then someone had 1,000, and someone had 500. Let's just print out this variable now, high scores. If we look in our console, what gets printed out is this value that has a dropdown where we can actually see, oh, here's 0, here's 1, and here's index 2. And then it also has this other property here called length, which we will use shortly. So if we wanted to print out the first element in this array, we would open up brackets here and type in 0. If we wanted the second element, we would type in 1. And if we wanted the third element, type in 2. And so now we should see 2,000, 1,500 printed out. 2,100, 1,500. And in other languages, if you try to reach into an array past the last element, this would cause an error. But in JavaScript, what you get back is not an error, but the value undefined. So we can say even though there's nothing in the array at index 3, so let me put this here. This won't cause an error. We will just get undefined. So unlike in some other programming languages, arrays are not fixed length. So you can add more elements to an array dynamically, and you can remove elements from an array dynamically. We're not going to do that in this demo, but just for context for people coming in with a programming background. We also have this really useful property called length. So if we have an array and we say .length, that will give us back the number of elements that are in that array. So we're getting back 3. And we're going to be able to use that to do something called looping over the array, where we can write some code that runs once for each element in the array. So let me show you 2 ways to do that. One is the functional approach, which means doing this via functions, which is a very popular paradigm in the JavaScript world, functional programming. So here what we would do is say high scores, and then we're going to use our dot notation to access a function that lives inside of high scores. So all arrays have this function, and this function, we can see a description of it here, takes a function as a parameter that gets passed into it. So the way this might look will be something like this, where I'm going to use an arrow function. So this is just defining a function in here and then giving it to for each. So what this function takes as parameters, this inner function, is the score and the index. And so this function that we're declaring here is going to run once for each element that's in the array. It's going to run once for 2000. So the score will be 2000, and then the index will be 0. And then it's going to run once for 1000. So the score will be 1000, the index will be 1, and then it'll run once for 500, and the index will be 2. So we can do something like console.log. The score at index is score. So I'm going to go ahead and comment out these lines so that we only see this printing out in the console. So we can see it's going through and running 3 times. So the score at 0 is 1000, the score at 1 is 1000, the score at 2 is 500. And if we want to express this without using arrow functions, we could say here is our print high score function that takes a score and an index. So if you're more comfortable with this syntax, that's completely fine. We're just defining a function and then using for each to run that function once on each element that's in the array. So I'm going to leave it as the shorter syntax, the arrow function syntax. And let's take a look at a loop. So this is one way to go through each element in an array, and another way is to use a for loop. So I'm going to write this out, and then we will diagram it out on a whiteboard. And we're going to print out the score at I is high scores I. So both of these are equivalent. This one is the functional form of looping over an array, and this is using a for loop to do that. So if I look at what's printed out in the console, we should see the same thing happening twice. So I'm going to take a quick screenshot of this so that we can diagram this in a whiteboard. So this is a highly compressed syntax, but what it is expressing is 3 separate statements side by side. So we have here this is our initializer. We have here our condition. And here is our update. So the way this works, this loop structure works, is that this initializer runs at the beginning. So this is creating a variable. We're using let here because the variable is going to be mutated. It's going to be changed and reassigned. So it's whatever variable you want to, the identifier is up to you. Here I'm using I standing for index. So we started at 0. Then this condition runs, checking whether I is less than the length of high scores. If this turns out to be true, so 0 is less than 3, how many high scores we have, whatever is inside of this block of code between the opening curly and closing curly will run. And when that finishes, this update will run afterwards. So this expresses that we want to take whatever I is and add 1 to it. So we started off with I is 0, this update runs, I goes to 1, and now we check this condition again. So is 1 less than 3? Yes. So then console.log runs again using I equal to 1. And when that's finished, we go to update. I goes from 1 to 2. And now we check our condition again. Is 2 less than 3? Yes, it is. So we print out the score at 2 is, and then we pull out whatever is at index 2 in high scores. Then our update runs again. Our I goes from 2 to 3, and this condition is no longer true. 3 is not less than 3, so our loop is done. We leave this code block and we go on to whatever code is next. So it's a lot of compressed syntax to look at for the first time, but it is really just parsing through whatever we put in the initializer, whatever we put in the condition, and whatever we put in the update. So let's flip back to code, and I'll show you one more way to loop over an array. So one other way that we can do this is to say score of high scores and print out the score is score. So this structure, we are actually just getting a variable called score, and the loop is going to fill it in with each element that is in our array and run whatever we put in this code block. So the first time through, score is going to be 2,000. Then the second time through, it'll be 1,000. And then the third time through, it'll be 500. And then it'll stop. So we should now see score printing out. We should see our 3 scores printing out from this, 3 scores printing out from this, and 3 scores printing out from this. 1, 2, 3. So all of these are equivalent ways to loop over an array and run some code for each element that is in the array. The difference is this is a functional approach. This also has the caveat, if you're coming from other programming languages and you know you can exit loops early, you can't exit this for each structure early. So if you're looping through and after 3 elements in, you want to leave, you can't do that. This is going to run for each element. This structure allows us to define an index that we go ahead and control and jump through the array, which allows us to do things like if we wanted to go through every 2 elements in the array, we could, or every 3 elements in the array, we could. And this third way is a shorthand for if you know you want to just pull out each element in the array and you don't care about knowing its index. So slightly different reasons why you might reach for each of these. Any of them are valid in this class. So let's see a slightly more complicated example that'll be closer to what we want to do. So let's say we have these trivia items and we're storing them in an array, And each element in the array is an object that has a question property. Like, we'll make these silly, like what is 2 plus 2? And then we'll have an answer, 4. And I will go ahead and grab this and copy and paste it. Change this one. What color is the sky? Blue. What is the first letter of the alphabet? We will obviously have much more interesting questions in our game. So we have this array. Each element, instead of just being a number or string, is actually an object. And we can loop over this. So let's use our functional approach up here. So I'm going to say trivia items dot for each. I'm going to get a trivia item and an index. So this function that I've just declared here, the first parameter I am calling trivia item, and the second one I'm calling index. And if we just go ahead and print out trivia item, and let's print out index, and check it out in our console, we should see the first time it runs, we are getting that first object, so we can reach in and grab the question and answer properties, and we're seeing that's index 0, and then the next one, index 1, the next one, index 2. So what we can do is ask each of these to our player. So we can prompt, and we will use trivia item dot question. So this allows us to reach into the first element here, grab the value that is in our question property, and then we can say, is the player's answer equal to trivia item dot answer? So here we are able to take this question, ask it to the player, pull out this answer, and compare them to one another. If it's true, alert correct, else alert wrong. Let's give this a shot. So what is 2 plus 2? 4. Correct. What is the color of the sky? Green. Wrong. What is the first letter of the alphabet? A. Correct. So this is much closer to the usage of a loop and the kind of data that we will store in our array compared to the high scores that we were looking at earlier. And just so that you have an equivalent example, I'll show you it with a for loop. So for let I is 0, I is less than trivia items dot length I plus plus. So we start at 0, we add 1 each time, and make sure that this loop only runs as long as I is less than the length of our array, which is 3 here. We're going to run similar logic, except we need to say the trivia item is equal to trivia items and pull out whatever I is. We are using that to index our array, to pull out whatever is at that location in the array. And this should run and do the same exact thing. So I'm going to wait for this to get through all of these and then refresh, and still works, still works, still works. So this was a real fast introduction to arrays, which allow us to store multiple pieces of information together. We're going to essentially do this, where we're going to have an array of trivia items that we will present to the player using our interface that we designed. And we are going to use conditionals, which we learned about, to check whether the player's response, so which button they clicked on, is the correct response or not. I'll make sure to link some extra resources on conditionals and on looping and arrays for those of you who are coming in and haven't seen those concepts before.